Let's look now at creating a Jupyter notebook through JupyterHub, and we are going to answer a question that's been sent to us by an instructor. So our course instructor has given us the address of the server where we can access the question. So we head on over there and we go and log in with the student account that we've already set up. After logging in, we are going to create a new Python 3 notebook. And we are going to put in this code. So this code block will have been emailed to us by the instructor already. So it's just a simple copy and paste. And the instructor will also have given us a file code. So we replace the square brackets file code with the code given to us by the instructor. So for example, this might be example question, so egg quest, and if we run this, it's going to kick out this error message, or not error message, a warning, which we can just ignore. The important bit is that this question has been loaded into our account now as this notebook. So the name of the question will be used as a prefix, and then that will be followed by our student ID. So that's going to be saved now for us in our workspace. So you can see now this newly created file as expected. Just coming back here, we are of course going to answer the question in that notebook, and then we will want to export our solution to the instructor. And to do that, we create a new cell here, and we are going to type in rm.save. And that's it. So once we go and open up the new file, make our changes to it, then we come back here and we run this cell. So we run save. We don't want to come up here and run this block again, because that's going to overwrite our solution. So we are only going to run this cell after we've completed our changes. Now, it's useful to go and save this notebook in our workspace because we can reuse this. So for our future questions, we can just go ahead and change the name of the question that's sent to us, and all the same steps apply. So we might as well save this. So save it as file loader. So that's now present in our workspace. You can see file loader here, so don't close that at the moment. Now let's open the newly created file. We can just click OK on all these warning messages, and now we can see the question that's sent to us by our instructor. So this first set of instructions is what we are working through now, so you can read that at your leisure. And you'll find down here the problem statement, and this is a simple one that we should all remember from high school. So if we are given this quadratic equation and we are given this line, we want to know the points of intersection between those. But before we get to that, in this question we are being asked to reformulate this expression so that it's easier to plot. So reformulate so it's suitable for creating a plot. Then we want to sketch this plot or this curve on the same axes as y2. And it says by using just 3 points. So it might occur to us, well, we've got the equation, we can just go ahead and create a series of points using our matplotlib type functions. However, in this question, clearly the instructor is trying to test that a student can sketch out a curve without a computer. So if you're doing this on pencil and paper, you would be able to graph this function if you knew how to formulate it and what points to use. So that's what we are testing here. And then the third part is just to find the points of intersection, obviously between these two curves. After this problem statement is a block which is just to fulfill the question which says that the graph of y2 is given below. So down here, if we run this block, we can see a plot of y2. So the straight line is plotted here already. And what we want to look for is where the question says, problem or solution formulation, and so this is clearly where we need to go ahead and create our formulation. And if we look at this problem, x squared plus 4x plus 3, let's write in here. And remember, you use the double dollar to create equations. So we type between the double dollar y equals x squared plus 2, or is it 4x plus 3. We know that we can solve this by completing the square. So in completing the square, we can write instead that this is equal to x squared. And this 4x, if we want to make, if we think about x plus 2 all squared, then it's going to have a 4x in it, and it's going to have a 4. So we want to add 4 to our statement, and so we need to subtract 4 to keep it equal, and then we've got the plus 3 left over. So we can rewrite this as x plus 2 squared, and that takes care of this part, and then we've got the minus 4 plus 3, so this is a minus 1. So if we run that, we can see that's our solution formulated. And so this is now suitable for plotting an equation out. So it's useful because we can see here that we have the minimum at the point x equals minus 2. So x equals minus 2, and at that point, when x equals minus 2, y equals minus 1. Then we can also identify a point at, well, that's the minimum, right? We can think about some other points. So we can say when x equals 0, y at x equals 0 equals, so when x equals 0, then it's 2 squared, which is 4, minus 1 is 3. So that's a 3. And then we know that to plot a curve, we need at least 3 points. And so we can arbitrarily choose some other point. And here we've got x from minus 2, and then we've got x at 0. So we can also add another one. We can say also x equals 2 gives us that y at that point is going to be. So that's 4 squared minus 1. 16 minus 1 is 15. So we can draw the curve from 3 points, x comma y equals minus 2 comma 1, 0 comma 3, and 2 comma 15. So we want to draw a curve through these 3 points. Now let's just run that. So we can see here clearly this is enough formulation, and Instructor should be able to follow our thinking in solving this problem. So we can create our solution plot now. Now in the solution you will be provided with this. So when you just scroll down in your notebook, this code is already created, so we don't want to interfere with any of this code up here. And here where we have this comment block that says include your lines and curves here, so you can do an add curve and you can add in your points here. So let's use this add curve part. So we are just going to add between these square brackets all the points of interest to us. So one of the points we had was minus 2, minus 1. Then we had 0, comma 3, and we had 2, comma 15. So these same points, -2, and apologies, I see an error here. This should have been a -1, right? So that's a -1. -2, -1, 0, 3, and 215. -2, -1, right. So now we are going to plot onto the curve that has been provided to us, right? This code has been provided by the instructor to give us the axes. And now using these 3 points, we are going to draw a curve. And if we run this, then we get that curve. So this is the straight line equation. So in the original question, we were given a straight line equation and we were given a quadratic. So for that quadratic, according to our formulation, we can draw this if we draw a curve through these 3 points. And so using draw curve, we have managed to include that as our sketch. So that's how we sketch in answering these types of problems. And we can read off from the graph the points of intersection right here. So down here, you will also find a block that's it's optional, but we can write in here some comments that can help the instructor to find our solutions. So part A asks us to formulate our equations. So C formulation in cell above. And then for part B, it's about plotting. So C plot above. And then for part C, the question asks us to provide the point of intersection. So once more, these were the questions: formulate the equations, sketch the curve, and then estimate the points of intersection. And if we just go over here, we can see a point around about -0,7, and that's about a 1. So we can write our solution here. Intersections on plot are about x comma y equals -0.7 and 1. So that's the first point of intersection, and we can see another point of intersection here, which is around 1.5 and let's say 12. Right, and that's basically our solution right there. And then there's a little reminder here to please go back to that file loader and run the save command. So we carefully save this notebook that we've been working in. We hit Control S, or you can go here and click save and checkpoint. And then we go back to the file loader and we just run this cell. And now it says our file has been exported. So that means the solution that we just created has now been sent off to the instructor. And that's it. That's how you can answer a question that has been posed by the instructor. There is another video that helps you understand how an instructor sets up the question, and that gives you a little more insight into how these notebooks are operated, and it gives you some ideas about other things you can do in your solution if you'd like. But this video is just about a straightforward addition of the solution into the document. And once more, this was pretty simple, right? The majority of this notebook has been provided from the instructor. All that we did in this notebook was to write in our formulation. That's still the question. So down here, this is all we did. We typed out our formulation for answering that question. And then we went over here and we just added the single line to plot out the curve. And then lastly, we provided a simple summary for the instructor to follow. So that's all we need to do. If you want more information about creating equations and making a better looking formulation, then you can follow the Programming with Python playlist, and the link is provided in the description to this video.